Hi, this is Shauryadip Chaudhary and we will take a look at Lookup. Lookup is a search server that allows the user to store and search documents, supporting full text search, binary operators and comparators. It operates on a custom document-based data store and a custom query language usable through a RESTful interface. First, I would like to show how it works and then we would get into the design of the application. Lookup follows a index, schema, entry hierarchy, which is similar to a SQL database's database table row hierarchy. The user is able to use Lookup through a RESTful interface. The user needs to send the put, post, delete request to the root URL of the server, while the user could send GET request or simply browse the database through a path based on the documents present. I have already populated the data store with the following queries. I would be showing you some fetch request I would be sending to the data store. If I send a fetch request on an index level, I would retrieve the schemas present in the index. If I send a fetch request on the schema level, I would retrieve the entries present in the schema along with the structure of the schema. So these are the entries present in the schema. Now, if I send a query in the GET request, I would retrieve the entries which matches this particular query. I have currently used the in operator. If I use the has operator, it would retrieve me a different result. If I add an additional condition, it would retrieve me the previous results along with the results which match this new condition. As you can see, I have these entries currently present in the data store. Now, let's get into the design details of Lookup. Lookup consists of three major components: the data store, the query engine, and the RESTful interface. First, let's talk about the warehouse. This component is responsible for performing all the I/O operations and maintaining the structure of the data store. Once it receives a request for reading or writing a document, it calculates the path where the document should be present and then performs the action. There are data models for each type of document that helps maintain the proper structure of the document before writing it to the disk. There are four types of documents present in the warehouse: index, schema, entry, and property. The property document is used as indices for searching and retrieving the entry. The module query engine has two subcomponents: the query parser and the query evaluator. You can see the flow of this component on the screen. The query parser is written using Parsley. This mainly consists of regex rules which define the query language. The evaluator requires a structured operation which helps to determine the action. The structured operation may come from the query parser or it may come directly in case of browsing the data. The third component is the server, which also acts as an interface to the user. The interface requires the correct use of RESTful verbs for each operation, and according to the type of request, the appropriate operation is performed. The user can browse the data store by using a URL with a proper path or fire a query in a schema to retrieve the entries as shown earlier. I am running Lookup on an Ubuntu VM. The data is stored as files which stores data in JSON format. These are the indexes. This is the index I was using. This index currently has only one schema. The schema's JSON has structure of the schema present along with the list of entries it has. We can take a look at the entries and we can take a look at the property files. The indices are called properties here and stores the name of the entry mapped to particular values. We can take a look at another property file. As you can see, all the entries are mapped to particular values. So if we perform a full text search, we can retrieve it more easily using these indices. I would now show some details about what kinds of operators are allowed in the query language. The query language supports all kinds of operators like less than, greater than, equality. It also supports binary operators like the has, in, the logical and, the logical or, the logical not, and parentheses for nested queries. And this is a Venn diagram representation of operators has and in. The in operator performs an OR operation between all the keywords, while the has operator performs an AND operation between all the keywords. So, this was all about Lookup. Hope you liked the screencast. This was Shauryadip Chaudhary taking a look at Lookup.